All right, so principles of bake shop. What we'll be focusing on, we're going to learn the importance of scaling, measuring the ratios for baking, and for success in that. We're going to talk about what's happening with all these different elements, flour, eggs, fats, liquids, leavenings, and we'll talk about the different mixing methods, how to get stuff mixed together to achieve the results we're looking for. Can you guys see that for me?
Yeah.
All right, so the principles is what we'll be focusing on. The important thing about baking is accurate measurements. That's the most critical part of it. Right, so our objectives, what are we here for? What are the objectives of this block? Again, there are special tools that you need for baking. Sifters, being one of them, sifting. The scale is important. Sometimes docking tools, pastry bags. Things we've been, there's nothing unusual, but it's important that you're using the right tools at the right time in the bake shop. The ingredients from flour, sugars, the different types of flours. Okay. Bread flour, baked flour, all-purpose flour, cake flour. There are different flours, and we'll talk about the difference, why you use those. The size of the sugar granules, granulated versus powder, how that works in there, the different kinds of leavening agents, whether it's chemical or yeast-driven. Controlling gluten, okay, and that's a big part of it. Flour is, 90% of most of the recipes, right? And so controlling the gluten, whether you want it to develop, how you want it to rest. Cooking sugar correctly, again, using chemicals for leavening, baking soda, baking powder, and then, what is the baking process, what's going on from there. So that's what we're trying to do. We've got formulas that we want to follow. Okay. So that's, the term for the recipes, right? We're going to follow the formula, the recipes. Very important that you, follow recipes when you're baking. It's not like making soup. It's not like making sauces where you can just kind of wing it and just put things together. Baking mistakes, though, are, you don't realize you did something wrong until the end. Until it's too late to try to fix it, which is important. So again, that accurate measuring, scaling is going to be very important. So again, precision's on there. You look in here on page 900, the mise en place. Exact ingredients in precise amounts. There are sometimes components that need advanced preparation, okay? Such as softened butter, right? Because you've got the temperature of the ingredients. Your butter needs to be softened beforehand. Maybe your eggs need to be room temperature beforehand. Okay, so paying attention to all of those things. Again, making sure you have the equipment, and you have the sifter, you have your the right pans that you're going to be cooking in. Refrigeration time, right? Do things need to rest? Do they need to chill before you cook? All of these are very important. And then oven temperatures required. Like that really should be number one. Right? And any baking recipe that does not have the first step, turn on the oven, sucks as a recipe. Right? Because you don't want to make your recipe and then go, you go turn on my oven, and then you lose it. So make sure oven control is so important in baking. Right? The right ovens, the right temperature, and getting in the right spot in the oven. Okay. So in ovens, you don't want to put stuff like right close to the door. I see this happen a lot with, I noticed it with the other students the other day. I'm sure you guys figured it out by now, but, when you put something in the oven, like put it in the oven, like slide it back, because that's where a lot of the cooking is happening, right up against, you have the sheet pan right up against the door. On the smaller things, obviously a full-size sheet pan fills up the whole oven, right? But sometimes you'll see, they have their little tray of potatoes, and it's like right there on the edge. It's like, well, let's get it in the oven, right? That's where it's cooking. So placement in the oven is going to be very important to understand that. All right. So tools and equipment. Again, the pans are a big part of, especially in the pastries, the tarts, different tart pans, tartlet pans, very important. Spatulas make it easier for spreading icing, especially the offsets or the smaller ones for the decorating, the fine tools, and then piping bags, different sizes, different tips, different size bags, and important, right? So we have the tools here that you want to see from the top. Cake turntable, right? So this makes spinning the cake. When we decorate the cake, it makes it easier to keep it even as you're spinning it instead of trying to roll around there or turn it on hand. Very helpful. Different types of cake pans, a flan ring, tartlet pans, the little tart pans there, offset spatulas, flat cake spatula, different things like that. Let's see. Cake bench scraper, which we love for scraping up our onions and other things too. The bench scraper is a really useful tool. Otherwise, that dough cutters, rolling pins.
Sure.
Yes.
What's that flour now for? Or it says flour now. It's like a little thumbtack.
Flour now.
Yeah.
Oh. So you'll hold it, and it's that flat part there. You're piping flours. And you spin it around, and that's how you get the rows, and then you slide it off and set it on top.
Cool.
Yeah. So most people's flour nail is a carrot on top of a toothpick, and that'll do it. Yeah, that's for piping. All right. Speaking of flour, a different kind of flour. So flour, it's the main ingredient. Okay, provides the bulk of the structure of our baked goods, but also thickens liquids, as we know, right, from roux, right, and can prevent things from sticking during preparation and baking. Right, our bench flour, right, we utilize our bench flour when we're working on our pasta. Okay, so useful there. So it's the milling of grain kernels. From seeds, we learned that in our starches class. With the seed, grains, kernels. There can be nut flours as well, though those, are flours, right? And so they'll work differently, but they can be utilized the same sometimes. But corn, rice, and wheat are the most common ones that you'll use for. But again, it's a grind, fine grind on that. The most common one being wheat flour, brought out by the wheat kernels, and the main difference is going to be the protein. When we talk about all-purpose flour, cake flour, pastry flour, bread flour, it's going to be the protein level. Right? They contain starch, they contain protein. Right? So what do starches do when heat is added to them? Gelatinize.
Oh.
Okay, and then protein coagulates, right? So we've got two different things happening when we're working with flours, right? And that's why baking is the challenge that it is to work with that, to get things right. You've got to temperature control, because those things happen at different temperatures. Very important. Okay. And then there's also, flour in the germ part. So the germ part's removed when you're making the flour, so there's not going to be any fat in there. You can see here in the picture when you squeeze the different flours. Like, this will help you know if you're confused as to which ones you grab, the protein content, how you squeeze it together, how it clumps, the difference of flour. You can see that in that picture there. So the things that are going to matter for us, again, is the protein. And so protein coagulates. We know that. So the more protein you have, the more coagulation, which means it's going to be tougher. Okay, so that's why the difference in protein in the flours. So bread flour, higher protein. You need that durability. You need it to hold together. Right? So you want the higher protein. Whereas in a lot of cake pastries, the delicate pastries, you want them lighter and softer. So you're going to have less protein. Okay, and so that's the difference in there. Now, can I make my little tart shells with bread flour? Yes. Can I make bread with cake flour? Yes. Okay, so, they can work universally, but the differences, are, noticeable to the trained eye for sure. And, some other person might go, oh, this one's kind of tough, or your bread's a little too, soft or doughy. But the differences are there, but they're not like end of the world. If you have to make tarts with bread flour, it can be done. Okay. So another phrase often is with the lower protein count, you'll hear it called soft flour or weak flour, as opposed to hard or strong flour there in relation to that. Moisture is affected by the climate, right? So like in Houston right now, probably a lot of moisture in the bread flour. Maybe not so much in here, even though so that really affects cooking times because it's so dry. It can take on that moisture that's in the air. So humidity affects your flours a lot, and minerals not so much in the ground, just plain white flour. You're going to get more minerals in your whole wheats and other flours. Again, starches. That's what is absorbing the moisture and taking it on. And then the protein. It's in the form of gluten. Okay, so gluten is a tough, rubbery substance created when wheat flour is mixed with water. Okay, so you can so it's when wheat flour is mixed with water, but also like temperature can do it too. So you have to time how your thing's doing. But when you're kneading bread, when we get into this bread, it's kneading. You're developing the glutens in that because of the water activating. Right? We just keep mixing dry flour, spinning. Like I could knead dry flour, and I'm not going to develop the glutens until water's added. So again, as we were saying, the protein count matters on that. I want to see what else. So you'll often see your high protein bread flours also labeled high gluten. I think that's how ours is labeled as high gluten. Mentioning that, but that the gluten is the type of protein that's in there. The range of protein, high gluten has nearly twice as much as the cake flour. So again, tender cakes, right? So if you make your cakes with bread flour, they're just going to be tougher. And you make your bread with cake flour, it's just going to be softer. You can see the protein range there. And then sometimes, so like to make pastry flour, we mix cake flour and all-purpose. Right? So you don't necessarily need to buy all of these. You can cut one and then mix them together and get your protein ratio.
I was going to ask that. But also, so if there's more protein, it's more tough?
Correct. Right. because of the gluten, because of the coagulation, there's just more of it in there. So again, specialty flours, the whole wheat, and that's you're just using the whole kernel in there. You're going to get a lot more minerals and other things in there, tougher texture. On their vital wheat gluten, this is just the pure protein extract from that, and you can get vital wheat gluten yourself. Like you can make that where you just knead the flour in a lot of water, like more water than you do. You just keep kneading that, and it will really get really tough. And you can separate the gluten from that. That's the way to do it. And then the self-rising flour has some salt and chemical leavening added to that. Then there are some non-wheat flours, grains, seeds, are some common ones, beans, so like chickpea flour, potato flour, also we mentioned rice in the other one too, with seeds and grains, other grains. But they do not contain the same protein, right? So they will develop differently, and that's a challenge for gluten-free bread. Get that texture of what we get from gluten. Gluten is the magic thing that makes bread do or wheat do what we want it to do for those types of things. And so trying to figure out how to make those happen without that. Rye flour is milled from rye berry. Comes with different grades on that. All right, so we talked about then, what's happening, with the flour. It's the protein is the main thing. What's happening is the development of the protein, the gluten. Is it resting? Is it getting tough? How it coagulates, right? That's the main thing. What's going on there is the gluten. Sugars. What's the function of sugars? And so again, what's happening with flour? It is, providing the structure. Sugars and sweeteners. They provide flavor, provide color from caramelization, but they tenderize products by weakening the gluten strands. Okay? Also will provide yeast. When we get into the bread baking portion of it, we're working with the yeast, acts as a preservative, and then one of the things that's going to be important for us is the creaming. Acts as a creaming agent, creaming and foaming. So when we're trying to cream butter or develop an egg foam method for genoise cake, you need the sugar, and it has to be granulated because a lot of what happens in baking is chemistry and physics and on a molecular microscopic level, and sugar crystals have sharp corners, and those you can't tell, and you think, oh, I'm going to cut myself with the sugar. No, you're not. But what it will do is it will cut the protein strands in there, okay? And so you have to know you're using the right sugar. So that's how it tenderizes. It's because of the shape of the molecules and things like that. So keeping that in mind. The and again, when we're creating egg foam or when we're creating meringue, okay, it helps set and stabilize those. So sugars have a lot of function on there. They are carbohydrates, different kinds. And we'll touched on this in some nutrition. What carbohydrates are, different kinds. Simple, complex, cane sugar or sugar beets. This is the most common sugar. I think we're pretty much all cane sugar what we use here. Don't use much sugar beet. Europe uses more beet sugar. The turbinado, different types of sugars, so specialty sugars will give you flavors and then sizes. The sanding sugar, larger crystals, for decorating. Okay, you will see that on there. And then again, granulated sugar. Then we have brown sugar. It's refined cane sugar with some of the molasses returned to it. So the process of making sugar It's kind of like, taking the liquid, the molasses out of it, and then to get back to brown sugar, you're putting stuff back into it. Okay? Different types, light or dark, and it just has to do with the amount of molasses. So if you ever don't have brown sugar, but you have some sugar and molasses, you can make your own brown sugar. Okay? And like molasses is will last forever. So if you have a jar of molasses that's 10 years old, it's still probably good. My wife wanted to throw it out. She's like, no, it's still good. Molasses can't go bad.
I give some of that to my plants when I make a tea
Mm-hmm.
or a compost tea, and I'll put some molasses in there.
Yeah.
Because it feeds the.
Mm-hmm. Yeah, lots of minerals in molasses on there. The superfine are the castor sugars, smaller size crystals, so they dissolve faster and they'll produce lighter, the tender cakes, and then powdered sugar. The starch is added to powdered sugar to prevent caking. That's why that's in there. All right, so liquid sweeteners. Molasses, again, that's a liquid product from the production of refined sugar. Corn syrup, all right, so it's very viscous. And that's why people use the corn syrup, is the way it's structured. Okay, it's almost like a binder, but it's that consistency of what corn syrup does on there. Less sweet than honey or even refined sugar, so you're able to utilize it. The thickness of it is what you're looking for on that, is what corn syrup has. Honey, created by honeybees, it definitely has a distinct flavor. Very strong sweetener on there. Fructose and glucose. So it's the multiple types of sugar. So when dealing with liquid seasonings or liquid sweeteners, know that the consistency will matter, and the type of liquid content in there. So corn syrup, honey, molasses. Those are the main liquid sweeteners. And if you're going to try to substitute, they work completely differently, though. Okay, so it's important to understand that. Another one is maple syrup, sugar from maple trees. Again, it's a reduction process. Right? You get that. You tap your maple tree, you get a bunch of sap, and then you reduce it down. It's really fascinating. You need like a 3 a.m. YouTube diversion. Just watch videos on maple syrup making. A lot of fun there. But I've done like side by side things. Playing with, like I make like a peanut brittle. I'll say, all right, make some with molasses, make some with honey, and make some with corn syrup, and see the difference. The texture will be different, the tackiness, the stickiness. So they are completely different. And then obviously flavor profile and visual will be different. Light syrup is 2 parts water, 1 part sugar. Medium syrup, 1.5 parts water, 1 part sugar. Heavy syrup, also called simple syrup, is just equal parts sugar, water. So 1 cup sugar, 1 cup water. That's the most common when you'll do that. Just bring it to a boil, and then that becomes your syrup that way. So like light syrup, that's when you like buy canned fruit a lot of times, and it says in light syrup, that's what the ratio is on that. Your yes.
Right here in the book, it says it measures a degree on the Boulomé scale. Do you know what that is? Talking about the light syrup, medium syrup, and heavy syrup. It's on 907.
Yeah. That's the
Like how sweet stuff is?
yes. It's a scale of sweetness. It's like that's one of those nerdy type things. Like, all right, this is the scale of the amount of sweetness and type things like your Scoville scale for capsaicin and peppers. Okay, so that's just the scale measuring sweetness.
I didn't know if it meant we had to cook it at that temperature or something.
No. So like now,
Or the degree.
you're just bringing it to a boil now, and that's not cooked sugar. Like when we don't call this simple syrup, even though you have to bring it to a boil and then stop it. That's not considered a cooked sugar. Okay, that's the next step. So at this point, they're just syrups. It's not a cooked sugar. The next step then is cooked sugars used in meringues, caramel, buttercream, other confections. So then once you start cooking sugar, then some other things happen, right? So we know, what's going on with happening with sugars. I didn't mean red sugar. But yes, right? Caramelization is happening with sugars. But then again, what's happening with the sugars, is tenderizing. So it's tenderizing. But now the temperature is what matters here, right? Because the sugar, like once it comes to a boil, boiling is just 212, right? And that nothing's necessarily happened to the water. It's just got to its max temperature, right? Now, once you go beyond 212, then water begins to evaporate, right? What happens with water? Then sugar starts cooking. Okay, and so that's why a lot of times it takes a while to make caramel, because you have to wait for all the water to disappear. Like it will stay at 212 degrees till the water's gone. That's when the water's gone, then you gotta pay attention. It's important that your clean saucepan. Very important. And then, because it can get impurities or oil and it can really interfere. Because you want to prevent recrystallization. You don't want it to recrystallize. Is that there's things, an interferent can be added to the solution once it begins to boil. So cream and tartar is one. Vinegar, sometimes lemon juice. We'll use that, and so that prevents the formulation of crystals.
Why does it say for copper on this
Because they're snobs. No, it's actually the, stop that. What I want to do. The transference of heat and the balance of heat is very even, and you're not going to end up with hot spots. And that can affect that if you certain pans have hot spots. But very few places. I've only worked in one place that had copper pots. So we won't do that. Brushing the sides of the pan with cold water. We'll do that also to help prevent the crystallization. So it's the temperature that you're going to get to will determine, he's got names, thread, will it make threads? Strings, so when you're trying to do that little garnish, making the nest, you need to hit thread stage. Then softball. And basically it's determined as to what happens if you put it in cold water. What's going to happen, right? To it. So it says, check the hardness with your fingertips. Let's go back to the other page and look at that safety alert. Safety alert. Hot
Put your
sugar.
finger in hot sugar.
Oh yeah, I got really bad burn right
Yeah.
here.
It says it causes severe burn.
Yeah. Okay, so again, what temperature does water boil?
212.
212. Okay, so you know sugar has to be much hotter than 212 to become caramelized. All right, and has anybody burnt themselves with steam yet?
Oh.
No, steam?
Yeah.
And
Now,
that-
boiling water is no problem. I'll stick my finger.
Steam hurts.
The steam hurt. Okay, so imagine like liquid steam stuck to you.
Yeah, you get stuck.
Okay,
You don't get it out.
so be very careful with the hot sugars, right? But so these names: soft ball, firm ball, hard ball, soft crack, hard crack. Those are what happens when the sugar is added to cold water. Okay, and then the next stage is caramel, when it begins to turn brown in the pan. Now, as cooks, we learn the line, that's not burnt, chef, it's caramelized. But there is a difference between caramelized and burnt. Okay, so keep that in mind. But these temperatures, all right, again, so you look at that, it's like 338 degrees. That's pretty darn hot, right? And so you make your caramel and you go, oh, how's that taste?
No.
Wow, no, don't do it. And then you think, well, maybe I'll just do it with a spoon. No, don't do it. Get a spoon, set it on the counter, go clean your station, and then sharpen your knives and do your taxes, and then maybe it'll be good.
For sculpting, would you use soft crack or hard crack?
That's a Chef G question, but I don't think you want it to go to hard crack, because then you lose the pliability. But there's other things you need to do to the sugar to get it pliable. There's something you add to it. I know for sure you do add the interferon on there, but I think it's pretty much soft crack. Is that, and I know he's been experimenting with like a range of degrees, like as low as softballs, like one guy says, or that. So
Hard crack looks like that old rock candy my grandmother used to make.
Mhm. Yeah.
Chef, so what happens if you put caramel in water? Is it like harder than hard crack? Since it's hotter? You know what I mean?
It will.
It'd probably be harder.
Yeah. So it will hit like those Werther's candies. So yeah. It'll be hard that. So, but a lot of times, like caramel has other things added to it. Sometimes butter or cream or some fat will change the texture. But yes, if it was just if you just caramelized sugar only before you added anything else to it, it would be like the hard crack.
Sorry, Chef, I'm a rookie when it comes to pastry.
So, no, that's all right. You're here to ask questions and learn things. All right. So again, what's going on with sugars? Caramelization, tenderization, flavor. Okay, those are the things that you're looking for on there. But the fact that it's a tenderizer is very important to understand that. Right? So, especially when you're making cookies and tarts, right? If it's too soft or you're not getting the rise or you're getting too much spread, then maybe my sugar ratio is off. Okay? On that. So fats, what do fats do when heat is added?
Melt.
Flavor code.
Oh.
Add more sugar.
Is it
So fats melt, right? That's what's happening there. And then its function provides flavor, color, moisture, richness, assists with leavening, extend shelf life, but also tenderize by shortening the gluten strands. Okay, so as you develop gluten, right? So these proteins that you're kneading them or whatever, they kind of hang on to each other and then make a long chain. All right, and so what do sugars do? They cut the chains, okay, and to shorten them. But then fats, they kind of make them greasy, and so they can't really bind as well. And so that's what's kind of happening with the shortening, right? Is why it's called shortening. So on that, it shortens the gluten. So fats will do that. So like shortening, you go get that Crisco shortening. Well, what is it? It's a fat, and it's lard or different things like that. You can create emulsions with them. again, keep that in mind. The most common one is butter that you're using, margarine. You will never use in my presence. Some places will use margarine, right? But it's different things, hydrogenated, that on there. But it is, because it melts at a slightly higher temperature, some people like to use it a little bit better just because it's easier to work with before you start losing that. Because the temperature of butter really matters when you're working it into things, especially laminated doughs or biscuits. If your butter gets too warm, too soft, and melts into there, it's not going to do what you want it to do to create flakiness. Okay, so again, 93 degrees is the low temperature for it, the melting, and our skin temperature a little more than that, right? Like 97. So if you're working it with your hands, some people run a little hotter too. So it's really important you get it cold for it to do. You need to do lard, rendered pork fat yields flaky and flavorful. Pastry shortening is other animal fats and vegetable fats that have been hydrogenated to make them solid. So shortening is usually a blend. Oil is a liquid. Sometimes you're just using vegetable oils. They'll blend throughout. So a lot of times you want, in those where you want a consistent texture, like cakes, that's where you use oil, fold into that. So throughout, where you want to blend it throughout the mixture, whereas sometimes when you're working butter into something like pies, scones, biscuits, you want chunks of the butter to exist, right? And then, so like what happens is when we get to making pie shells, you'll have these layers of dough, and in between these layers of dough, you'll have little pockets of butter. Okay? And as the butter, the fats melt and the steam, kind of leaves, kind of gaps there, and the flour cooks around that, and that's what gives you your layers or your pockets, your flakiness. Okay, when we do the laminated doughs, when we get to that, you have a layer of dough, a layer of butter, layer of dough, and you keep folding that over, and so it's that butter that's in between. But if your butter gets too warm and melts, it doesn't create a separate layer between those, and you're not going to get your flake, you're not going to get your rise, you're not going to get your texture that you're looking for. So that's why it's important to that. Now, lard has a different mouth feel than butter too, so things that are made with butter versus lard will have a bit of a different mouth feel to that as well. So again, that's what's happening with our fats. Right? They're melting. They're providing flavor. They're giving rise and lift and assisting with the leavening from that. We've got next is our chemical leavening agents. Right? So this is, what does leavening mean?
Rise.
To rise, right? To bring it up. The ones that do these are chemicals. So baking soda, baking powder, baking ammonia. You'll probably almost never use baking ammonia. I never have, but it's used a lot in some cookies, mostly crackers, on there. So going back to the sodium bicarbonate, baking soda, it's an alkaline compound or base, releases carbon dioxide if both acid and moisture are present. Heat is not necessary. Okay?
Which one?
On the baking soda.
So baking soda and water create CO2?
Not until something reacts to it. It needs the acid, both acid and moisture.
Oh.
So if you just put baking soda in water, nothing happens, right? But everybody remembers making the volcanoes, for the science fair,
Oh, yeah.
Mhm.
right? So the base and the acid work together. Okay. Now, on that. But you'll see there the acids commonly used with baking soda are buttermilk. Right? You don't think of buttermilk necessarily as an acid, but it is. Same thing with sour cream. Okay? And then lemon juice work with that. Okay? So they'll, and then even the citrus acids.
I know honey was acidic.
I didn't either. And I don't know like how many times I've read this and then just like, yeah, honey. I just probably forget on that. Let's see. All right, and then there's baking powder. So it's a mixture of sodium bicarbonate. So the soda is the singular one. There's just baking soda. Baking soda, singular. And then baking powder is a mixture of baking soda and some more acids, generally cream of tartar or sodium, whatever, aluminum sulfate. But it also prevents starch, from lumping, balance of chemical reactions. There's the single acting and the double acting. So single acting requires only moisture to begin releasing the gas. So this is where timing becomes very important. Like I mentioned, if your oven's not on and you use a single acting baking powder and it starts acting before you get a chance to cook it, you're going to lose your rise. Okay, so that's why first step, get your ovens on. Must be baked immediately. Okay? Whereas the double acting is again more popular than the single acting. The gas is released upon moisture, and then a stronger release of gases happens when heat is added to it. So they don't need to be baked immediately. They can sit for a short time. You don't want to let them sit overnight or what have you on there. And again, baking ammonia just produces crisper, things like that. So low moisture is the key on that one too. Low moisture. You don't want to use it in breads or muffins on there because that ammonia flavor will stay in there. All right, so that's what's happening with our chemical leavening agents. It's the chemical, right? It's the addition of acids to that. So if you're baking and the recipe calls for buttermilk and you don't have buttermilk, you can substitute sour cream thickened with a little milk for that texture, or you can add a little lemon juice. Like if you have, milk, then you can add lemon juice to it, or a little heavy cream and lemon juice. But you need the acid that's in buttermilk. Okay, that's why a lot of the recipes call for buttermilk. And the baking, it's the acid aspect to get it to react with that. All right, so our different thickeners. Okay, so we've used starches, right, gelatinized, absorbing the moisture, trapping the liquid in there. Gelatinization, if you're using actual gelatin as a thickener versus a starch. Gelatin is the protein's trapping liquid, whereas the starches are absorbing it. Cornstarch, arrowroot are the main ones, but cornstarch is have we used arrowroot in here yet?
Yeah.
A couple times, yeah. Like I personally prefer arrowroot. I don't know why. Maybe I picked that up from a chef. Maybe one told me that it was better, but I have that preference for arrowroot as opposed to cornstarch. But it's a thickener. And you have to dissolve it in cold water first, the thickeners. And it doesn't necessarily have to be water when you're making the slurry, right? Baking, you don't want to, make your slurry with chicken stock necessarily, but tapioca is another one, tapioca flour or the pearls, tapiocas, but the thickeners, absorbing, and they're just giving structure, helping give structure, texture, body to that one. So there's, again, the different kinds of gelatins. Down there, there's the sheet gelatin and granulated gelatin. Derived from animal protein, right? So vegetarians, vegans can't use gelatin in there. So Bavarian cream pie, can't serve that to vegans. Some vegetarians that will eat the dairy and lacto can do it, but that would be that. But so granulated versus the sheet gelatin. All right, the leaf. How you bloom it is different. And you have to bloom it. Like you have to get it to absorb the water and then utilize it. Granulated, you mix in the water sheets. You just put the sheets in the water, let them get soft, and then pull them out. Like you don't use the water after the fact. But with the granulated, you're using the liquid. Okay, so it's just enough liquid to get it to dissolve and become that. So, but first you want it to bloom on there. It talks about like envelopes, little packets of envelopes. It's a 1/4 ounce, or you can envelopes, or you can get it in bulk. You have it in bulk in there. Ratios, you can figure that out. Looking at that, depending on what the end texture you're trying to get, your ratio of gelatin to liquid on there. So if you want like a soft mousse-like consistency, or you want it to set up into a firm gel, there's a ratio on that. The sheet gelatin, you don't need to melt it first to add it to hot liquids, whereas the granulated, you do need to melt it first to add it in there. But you can add cold sheet gelatins to the hot liquid in that. But if you don't melt the granulated gelatin and add it to the hot liquid, it's going to clump up, and you'll have little pockets of granulated. So even if it's dissolved, if it hasn't been melted first, you will clump up and it won't function properly. So you need to melt the granulated gelatin first on that. And so those are our thickeners, right? So good, we got thickeners on here too. All right, so again, providing structure, helping with the texture on there. Flavorings. Okay, different kinds of flavorings on there. Right, so flavoring is very important. Our objective as culinarians, we want things to taste good. So how do we get flavors in there? There are some common flavorings. The most common one in baking is vanilla. Everything has vanilla. But vanilla kind of gets a bad rap. It's like, oh, it's just plain vanilla. But like, it's in everything because it tastes good. There's a reason for that. Like, drink milk and then eat some vanilla ice cream and then tell me vanilla's plain. No, it's a huge difference. And then go buy some vanilla and then tell me it's plain. Don't go buy vanilla if you can't afford it. It's crazy expensive now. But it's one of the more common ones. And then chocolate on there. Again, big ones there. So the flavorings, what's going on with flavorings, adding flavor. Essential oils and extracts and emulsions are some of the things you're looking for, to create flavor. So an emulsion is, flavored oils mixed with water and the acid of the emulsifier. That's what's going on there. They're stronger than extracts and should be used carefully and sparingly. I don't think I've even used emulsions in a lot in my baking career. Maybe. No, I can't say I have. It's mostly extracts that I've used. And again, a little bit of extract goes a long way as well. So be careful with that. So the chocolate, different parts of the chocolate. You look at that, you've got the chocolate bean, you're crushing them, removing the shells, different parts of the flat. When we get into the melting chocolate and tempering it, okay, this is again where science is going to matter, getting the right temperature on a molecular level to get that hard crack, to get the crunch. To do that, you have to set it to get it to right temperatures, but then there are different parts of that. There's the chocolate liqueur, the cocoa butter, the cocoa powder, and then conching, which will improve the smoothness, and then alkalizing it, the texture, how it interacts with things. There are some nutritional benefits of chocolate as well. That's the mineral content in there. And again, texture will matter. Yeah.
So a chocolate liqueur doesn't mean it has alcohol?
No. So like the phrase liqueur doesn't mean liquor.
That's what I
Right,
always
yeah,
thought.
yeah. So liqueur is like an extract, the liquid extract of something, right? Now, but if you go buy like chocolate liqueur, it's like a Godiva, it has liquor in that.
Oh.
So, again, be careful, but liqueur doesn't necessarily mean alcohol.
But it's okay that if it does have alcohol.
Yeah. Mm-hmm. Yeah. And, alcohol is one of the big flavoring that is in baking. You bake with a lot of alcohol. Again, different types of chocolate, whether it's unsweetened, bittersweet, or semi-sweet, has to do with the liquor being added back into it, cocoa butter, sugars, other things added, emulsifiers, again, to work on texture. So the different types that you utilize for baking, whether it's the couverture, milk chocolate, or the chocolate chips. And there's different size on the chips, often chunks, or bars. Comes in different ways. It depends on what you're wanting to do. Is it going to, become for a chocolate mousse? Is it for chocolate bars? Are you making it for dipping? Do you want it to set? And those things, the butter ratio matters on that. Again, milk chocolate will have milk and other things added to that as well. Cocoa powder, contains no sweeteners or flavorings, so it's just the pure form of yeah. And I used to, it's like, I want to eat the chocolate. I want to eat, because I like chocolate cake. My mom's like, no, you can't eat that. It's nasty. You're not going to like it. It's chocolate. I just wanted a spoon of the cocoa powder, and I'm like,
that's when I found out I was a kid too. I called myself being sneaky, got a whole spoonful.
She's telling me you're not gonna like it. No, I want it. It's awful, right? It's just
Like coffee?
yeah.
It's like dirt. Yeah, it's like putting dirt in your mouth and trying to.
So then the cocoa butter. So like white chocolate is pretty much cocoa butter. It's the fat that comes from the bean, right? It's a byproduct. It's like no chocolate solids on there. And then obviously imitation on there. Another flavoring element, nuts. They're high in fat, which makes them susceptible to rancidity, going rancid, going stale there. So airtight, non-metal containers. Peanuts are not technically nuts, but legumes, beans, work on that. But nuts utilized a lot for flavor, for texture, different kinds of hazelnut paste utilized in Nutella. Everybody loves the Nutella. Macadamia nuts, pecans, pecan pie, pine nuts, used a lot in Italian cuisine on there. Pistachios, the flavor, and the walnuts. And so again, basically the functions of all the ingredients. We're going to talk about what's going on. There's that table on 919. What our leavener's doing. We haven't got there yet. Yeah, we didn't talk about eggs all that much. I guess it was more in the top flag on that.
I mean, on the next page of the notes, it's just a little thing.
Yeah. Go back.
Wait, an egg can extend shelf life?
Yeah.
I would have thought it could.
No, once they're cooked,
Oh, okay.
all right. So precise measuring is very important. We're going to talk more about that tomorrow. When we talk about the baker's percentage, we'll just a little bit more, and then we're going to head into the again, precise measuring, very important. What you're doing there. So on the next pages, we're going to talks about calculating baker's percentage. Read over that tonight on that, because that's what we're going to discuss tomorrow, the baker's percentage and the scaling on that. What we're going to be doing today is making some muffins and stuff. Talk about what happens on when stuff bakes. So the baking process. All right. So what's going to happen once we've mixed everything together and after we do that. So how do we mix ingredients, then bake them? If you want to know. Different methods for that. So how you mix it affects the end result. It's very important to understand that. The goal of mixing, distribute your ingredients evenly. They create the texture, activate proteins, incorporate air if you're going to help it rise. So how you mix it affects the rise as well. So air is a leavener on that. Change the texture, and again, the different methods ensure that things are mixed the proper way to get the end result. So, you look on those mixing methods on 923. Start with beating, blending. So the different tools that you can do that. Creaming. Okay, vigorously combining fat and sugar while incorporating air. Electric mixer fitted with a paddle on medium speed. Okay, so that's, you cannot cream on low speed. All you're doing is blending or beating at that point. You're not getting the creaming that you're looking for because you're not going to incorporate the air. So it's that speed of that, vigorously getting that. Cutting, right, using, incorporating the fat into dry ingredients until only lumps of the desired size remain. So there will be chunks of it.
It's like for the biscuit?
Yeah, like for the biscuits, okay? that's that. Or pie dough, and you want chunks for that. So if you're using an electric mixer fitted with a paddle, this one's going to be on lower speed. Okay, folding. This is a very important aspect to fold and fully incorporate, but not to over-mix. Okay, because if you over-mix or if you fold vigorously, you're going to break down the air that's involved in that. Using a rubber spatula or a balloon whisk. Okay, so this is, again, putting whipped cream or whipped eggs into batters or that. So if you're folding in flour into something, this is where it's important that you sift the flour on top so it lightly, evenly distributes, and then you fold that in and then do it in stages. Because if you try to put all the flour in at once, it's just going to clump or crush the lift that you're trying to get. Okay, sifting, again, through the wire mesh, or sometimes it's a drum sifter. Sometimes you can use a sieve as well if you don't have one of those crankings. Then stirring, it's just gently mixing ingredients by hand until evenly distributed. And then whipping, beating vigorously to incorporate air. Okay? And we learned that making mayonnaise and hollandaise.
Yeah.
Right? You want that lift, you have to vigorously incorporating that. So we've mixed things together, right? And so what's going to happen next?
Put it in there.
Put it in the oven, right? Which we've already
Turned on.
That's the first thing we did.
I have a question about like sifted flour versus non-sifted flour. Like you measure it out. If you measure sifted flour a little more than non-sifted flour,
No, like you don't, like when you measure the flour sifted, like if you measure by weight, like it doesn't matter if it's sifted, right? So that's why we measure by weight for the baking. Okay, so the sifting is just to make sure there's no clumps and it's loose and that it's able to mix together. But it won't.
And usually you sift after you measure it.
Yeah, but sometimes I get, say, 1 cup sifted flour. It's like 4.
so those measuring cups are supposed to be for liquid.
Yeah, but
What about when it's like how you?
but if it says like 1 cup sifted flour, you get 1 cup of flour and then sift it, into the ingredient. Like don't sift the flour into a cup. That way, yeah. But if it says, 1 cup flour, use like a measuring cup for flour, right? Because how much does 1 cup of flour weigh?
It's different.
Right. What's a cup? How many ounces is in a cup?
8.
8. But how many ounces is 1 cup of flour?
Supposed to be 8. Based upon you would think it would be based
You would
upon
think.
Yeah.
You would think, but it's not.
Right. The
Okay?
weight is there, so like.
You can push it down too.
Yeah, so, and we'll go ahead and do that. Let's measure a cup and weigh it and see what the difference is, right? All right, so as the baking process, things occur when we're baking. A lot of things are going on, right? We have all of these things in there. Flour, which has protein and starch, right? So there are the 10 stages. Gases form: carbon dioxide, air, and steam. So our leavening agents are creating carbon dioxide, right? Air could be from the mixing method, right? We folded something into it, then steam, right? Water evaporating. The gases get trapped, though, right? It's that stretchable protein in the batter, and the dough captures it. And then the starches begin to gelatinize at 140. So that as they gelatinize, right, they get larger because they're taking on the water. So they take on that moisture and they expand. Then our proteins begin to coagulate. All right? And so at 160 degrees, that's when the gluten and the dairy and the eggs begin to solidify. Fats are melting inside there. Okay, so as the fat melts, it coats the starch granules, moisturizing and tenderizing, keeping gluten strands short. Water evaporates. Steam, which can be used, again, as a leavener, is produced. Sugars can caramelize, add flavor. Carryover baking, right? We talk about carryover cooking. Happens in baking as well. Okay, the residual heat, especially like in cookies, like shortbread cookies. Like if you cook them till they're what like a shortbread cookie should be like in the oven. When it comes out, go pave your walkway because they're going to be too tough than that. All right, and then staling. Right, that's when things go stale. Right, that's just the exposure to moisture loss or changes in structure and granules as things sit. Right, so you like stale cookies or stale bread changes the texture. So that's what's going to happen to all the goodies that we're dealing with there after we mix them. What's happening? All right, so mixing methods. Different kinds of mixing methods on there. And we'll get more detail into that. All right. So we're going to do some muffins.
Are we going to reduce that recipe?
Yes, we are.
Oh, man. We don't want to make it 25.
And so we're going to be in groups of 2 today also as we work into that. All right, so we've got the berry muffin and the jalapeno cheddar. If you look at the recipes, it talks about method, muffin. Okay, so it says muffin method. Now here on the berry muffins, it talks, number 2. Like it's 3 steps, right? But if you look at number 2, there's more than 1 step inside number 2, right? So when you look at recipes, like you have to, again, especially baking recipes, you really need to, all right, what's really going on here? And, things that I like to do is, have like code, like I circle actions, and then I underline, specific ingredients and focus on those things, right? So sifting, all right, well, we're going to sift. What are we sifting? So sift flour, baking powder, baking soda, salt, cinnamon, and sugar. All right, so that's 1 step. Is there sifting that? In another bowl, well, this should be like step number 3, really, right? Step 1 is mix that together. Step 2, in another bowl, right? It's important that if you think, step 2 is just, well, let's say I got flour, then I've got my wet, and right. So understanding that when you read recipes, the number by the side doesn't always mean it's only one thing to do in there, right? So then you mix eggs, milk, and melted butter. Okay? So we've got two separate bowls, wet ingredients and dry ingredients. Okay, so the muffin method is incorporating wet into dry. That's the muffin method. Okay. So you mix in the well, stir in until just combined, then add your berries and sugar. Combine using a portion scoop. Okay. Muffins into muffin cups. No, we're using muffin pans. We're not using cups. And then bake until 20 to 25 minutes until a cake tester comes out clean and the top so nicely brown. Okay, so what's a cake tester?
Toothpick?
Oh, there's cake.
Yeah, toothpick. Right? But they sell like you can go to Williams and Sonoma and you can spend $5 on a little thin piece of metal with a fancy
I
handle
use
on it.
that to check the dullness of my beans.
Yeah. or you can just use a toothpick, right? On that. All right. So sometimes you'll see recipes, and it will say, step 1, preheat oven. Yay, that's good. Step 2, mix according to muffin method. Step 3, cook for 20 minutes. Okay, so you will see recipes like that will say mix according to muffin method. So you have to know what the muffin method is. So what did I say muffin method was?
Wet.
Wet and dry. Okay, so you're separating the ingredients and mixing them together. You just can't, start putting it all together at once. Okay, so it's important you understand that.
Chef, is the biscuit method the opposite? Or am I wrong?
The biscuit method is cutting fat into there.
Oh.
And then adding a little bit of liquid, but it's cutting the fat on that. All right, and then we'll talk about the creaming method, the biscuit method, and the muffin method. Okay. Do you know the muffin method?
So by how much are we cutting it?
So it's going to be cut in half. Both recipes will be cut in half. And, you'll get plenty. You'll have stuff to take home. Don't you worry. Yes?
I've seen on a lot of recipes that have like fresh fruit added to it. They say to coat it in like flour so it doesn't
Yes.
stick to the bottom. Is that necessary?
Yeah, so we're gonna talk about that next. So, when using fruit. So fruit is very high in moisture, right? So it's going to release that moisture. Whether you're using fresh berries or frozen berries will affect it differently too on that, how you do that. So when you're wanting to incorporate fruit into things like that, having that flour on the fruit kind of like gives it that coating, that moisture, and then just helps it stay in there. Whereas if it's wet, it kind of will sink through. So lightly tossing it, just very lightly tossing it in the flour beforehand will help with that on there. So we're going to be using frozen blueberries, and then I think some guys, we're going to cut some strawberries. Got to double check what they got for us, but we're not going to be using the raspberries. I think it's just blueberries and strawberries on there. So again, portion scoops. Why do you use portion scoops? Even sizes, right? And so that way we know everything in that pan is going to cook evenly, and then cost control, very important. We're cost controlling. When you use liners, like this talks about muffin liners or cupcake liners, you lose rise, right? You don't get as much rise, but then you have something to serve it in, right? So when you have cupcake liners on there, just keep in mind you don't get as much rise as you do there because it's got the crinkles on there, right? So that surface area is going to be a little bit tighter, and you get more rise out of nothing. So if you ever make cupcakes and go, well, it didn't rise as much as I thought it would, well, it's because of the liners, holding on to that. All right. So the jalapeno cheddar muffins. All right, let's talk about that. Right. So you look at this one. It's like when we're making muffins. This one has 6 steps, and the other one had 3 steps. Right. Well, that's because this recipe broke it down separately. Right. So step 2 is stir together your dry ingredients. Step 2 again, there's a typo there, is mix together your wet ingredients. Okay. Then it should be step 4, mix dry and wet together without over mixing. Then gently fold in corn kernels, cheese, jalapeno peppers, portion the batter, and bake. So baking time will vary based on what? What else?
How hot the
How
oven is?
to,
How many pans are in that oven?
Pans are in the oven.
how many times people open and how long they leave it open for?
Also size, right? So, like maybe we're using, extra large muffin tins, or we're doing mini muffins, or we're gonna cook it in a cast iron skillet, or in a loaf pan, right? So, any of these can be cooked in different service vehicles, but keep in mind that will affect the time. So size will affect the time. Size matters, as they say.
So if we do something like that in like a cast iron skillet, would we want it more of a broader range of volume, so not so much like width of it, you want it evenly fit, not like a cake.
Right.
Cast iron.
Yeah.
Easily.
Yeah. It could cook faster if it's thinner, right? So again, it just depends on that. But the portion scoop, also is going to be important for the cook time, so controlling the cook time. So again, tomorrow we're going to talk more about the baker's percentage and scaling and accuracy, but measuring is very important on there. So. So the berry muffin says 3 cups all-purpose flour. So what does that mean?
Reduce about
One and a half
half.
cup.
Okay, and then cups,
12 ounces, sir.
wrong.
Well, it should, no, because it's,
It says cups. It didn't say ounces. But then you look at the cornmeal or the cheddar muffins and it says 12 ounces.
now you.
Okay? So that you use ounces there.
Just cut everything in half.
Right, you cut everything in half, but what I'm saying is, cups versus ounces. When you look at the recipes, use what it's telling you to use. Okay? And that's why metric is better. Oh, I'm going to say. And I say that, but I don't use metric myself either. But it just, you don't have to, is it cups, is it ounces? No, it's just grams. Weigh it out. Don't mess with it. Okay? But that's just crazy.
Is that why our means that we have for class, I've noticed it on, it says chest pulled out first, it's all in metric. The weight of it. Because we had it to a T when
Yeah.
we're not a class.
Yeah.
Is that why you have it?
Yeah, it's just,
Like a minute.
yeah, it's easier and it's more accurate.
It's precision.
I noticed that on the
Yeah. Yeah. Okay, wait for it. Any questions, Dawn?
No, sir.
Oh, yeah.
Oh, excellence. What is excellence? That's great. What is excellence? Excellence is planning. You have to plan for excellence. It's not an accident. You have to plan. I wanted to say this beforehand because baking is all about planning. You have to follow the steps. And excellence, it is achievable. People have accomplished it. It's part of our mission statement to prepare you to exemplify excellence in the culinary community. So we can say, we're going to prepare you to exemplify excellence. Well, what does that mean? How do you get prepared? You have to plan for it, right? And so planning ties into mise en place, ties into, what our objectives are, right? And so we have our lesson plans and then we have our learning objectives. This is how I plan to get you guys to learn what you need to know. This is our recipes are how we plan to accomplish the end results, what we're looking for. But the planning involves, the steps, and you can't skip steps to achieve excellence. So when you have a plan, you have an idea, right? You can't skip the steps, right? Because when you try to, you're going up the stairs and you try to hit that third step, and you're going to trip and you're going to fall, right? Okay? You're going to face plant. So don't skip the steps, when it comes time, so planning, follow the plan you make, right? And so, we have our syllabus, we have our course outline, we have our recipes, right? But having a good plan is important. Having a usable plan, but also number one, like a plan you're willing to follow, right? And so